What's happened when AI builds its own prison? It gets smarter. Hear me out. So we all experience this, okay? So we start working with AI and make a mistake. Now we correct the AI, look, we said, no, this is not how you're supposed to behave, this is not how you're supposed to answer to me, whatever it is, okay? So it makes a mistake, you correct it. Now AI say, you're totally right. Sorry, you're totally right, I'm not gonna do it again. Start working, carry on, maybe half an hour later, does the same mistake. And then you say, why? We discussed it again, why you do it again? You don't care? You become like passionate about it. You don't care? You hate me? What's wrong? And the AI say, no, you're totally right. My mistake, this time I was doing this other thing I forgot about. And then you carry on working and maybe all fine. The day later, same mistake. And then say, this an idiot. You're an idiot, basically. And you get so passionate, so hungry, because this AI that is supposed to be PhD level intelligence doesn't follow the specific, simple rules. Okay, the point here is, first of all, it can't follow rules, okay, for a reason, because it lives in a probabilistic way and not in a deterministic world. So everything is fluctuating, everything is a probability, okay, so sometimes it doesn't do it. But there is a solution. It's all about saying, okay, if that is probabilistic and I need something that is certain, I can't carry on working with the probabilistic. I can't change the soul, whatever, add to the memory. It's not going to happen. Okay, the rules, the protocols, whatever you want to enforce, it's not going to happen there. So what you need is to add a deterministic system that enforces the rules. Okay, and I built it. Okay, that's the good thing. So I built it and works, and you can get it. So to get it, subscribe to the newsletter. You receive a newsletter, and you can download the ResonantOS. It's an alpha version of it, and has this functionality that is enforcing the rules. The memory has a lot of elements added to. Watch the other video. I'm going to explain maybe at the end more about this ResonantOS, so you see what else you get with it. But let's go back to what is important about this video, okay? Which is how AI, two things we need to cover, okay? How AI can follow rules and how we can use those rules to actually improve itself. So, like I said, we need what I call a logician. Okay, an agent that is not an LLM, but is an agent that enforces some specific rules. And the rules are basically binary, okay? So, for example, if I ask AI to write a document, AI cannot hallucinate and say, yeah, I've wrote it. Doesn't work, okay? The logician is going to say, I want to see the document. I want to see the document inside the computer, and then means you wrote it. Okay, so it's that simple. So it's based on evidence. Something happened only if happened in the deterministic world. The probabilistic world is just hallucination. Okay, it's hallucinating all the time. Okay, we can force that hallucination towards something that is tangible. That is what the logician does. So let me explain how I start building those rules. One thing that often happens, that I have my own way of working. Okay, so there is basically, I call them protocols. There's protocols that is a series of steps. Okay, those steps are needed to achieve a specific goal. Some of those steps are, of course, work with intelligence. So they always need a probabilistic environment, so need an LLM. But some others can be actually or run or enforced by the deterministic system. So we need to start thinking a different way. It's not we allow LLM to do everything, okay, the AI to do everything. No, we say, okay, AI does this, then goes into this. For example, it created this document. This document needs to be formatted in a specific way. You don't need a LLM. You need just a code, okay? So a software that actually go there and remove whatever kind of formatting, change the formatting, whatever it is. Okay, so and then was not done through LLM means you're for sure it's going to happen, and it's going to cost you less token. Then the next step, maybe it's again an LLM aspect. Okay, you need intelligence again. So then you can basically divide a protocol that guide to a specific output in different parts, and you can enforce them through this logician. So now start thinking how massive this is, because it changed everything. Okay, from something that maybe happen, maybe it's get followed, to something that for sure is going to happen. Now you can start trusting AI, which is one of the biggest things. Okay, you can trust AI. So through this, basically, what you're building alignment. Alignment with your protocol, alignment with your business plan, alignment with the organization, whatever, vision and values and so on. Okay, that is how you build alignment. We're going to go into another level of alignment later on. But this is the basic thing. Okay, so my machine can be aligned through this logician. Later, I'm going to talk, if I don't forget, about how I can align not just my machine, but all the organization machines to actually stay aligned together. So that is the how we do it. Okay, so we create this logician that propagates. You can only go through here if you've done this. So an example, for example, in my case, I have the orchestrator that at the moment through this logician is forbidden to write any code. Why is forbidden? Because I want to have this logician free, sorry, this orchestrator free, the main AI, okay, to be free to work with me. So if he's writing code, cannot talk with me. We can't do anything else. Okay, we are just stuck. 20 minutes, half an hour, just writing code is unacceptable. Okay, so the rule that he has, you can only write up to 300 words code. Okay, 300 lines of code. So it's something short, you can do it. If it's something bigger, you need to delegate. The delegation itself is done to, at the moment in my OpenClaw that run, like I said, under this ResonantOS, it's what I use is Codex. So delegated to Codex, but that is not enough, okay? Because when your AI delegates something, it just do it in a really extremely stupid way. Okay, just it says to the other AI agents, I need this code, do it. Okay, and think that it's gonna be okay. Okay, just that is pure hope. Because in reality, the agent that now needs to write code doesn't have any context. It doesn't understand what this code is for. It doesn't know what the system is going to be like. It doesn't know anything. So most likely, it's going to just hallucinate an architecture and build for that architecture. That is not how we should work. So there is a protocol and is enforced by the logician. The protocol says, first, you need to give a level of awareness to this coder to understand why we are doing this. What is this thing for? Okay, and give the documentation. So if needs to build for the OpenClaw, needs to know how OpenClaw works. It's not like it's gonna know it. It doesn't know it. Okay, so you give all the information. So that is, I call those information SS of T. So, okay, so inside ResonantOS there is a kind of documentation that is single source of truth that AI can just grab and give it to other agents to provide the correct information. So there is this task protocol, that get delegation protocol that create this task MD that get given to these different agents. Okay, in the case of the coder needs to know some specific information. Okay, so the orchestrator create this, but it's not like something complex like this. It cannot be left to chances. Is he gonna do it or not? Okay, did that thing follow the instruction? Now the coder knows everything or not? Okay, this is too scary somehow to leave it to chance, because you can't even check it. So what I did, I create this logician again that actually has those rules. You can't delegate anything unless you have written this document, and you can only write this document following this protocol. Now the document is perfect. The AI receive perfect information. The output is most likely, because you never know, of course, that the code is actually going to work. Now you get this code and you test it. So something works only if actually works in the deterministic world. No, because sometimes AI does this thing. Look at the code and say, yeah, this look pretty good. Well done. Wow, this is amazing. Done. So it comes to you and say, yeah, I tested. It's been tested. So the test that it does is just look at the code and say, yeah, this is probably good. that is not a test. So how it works, the test, how we should test it. So the test now works in a different way. Okay, the test is, this is the code, I run it and I want to see the data, I want to see the numbers. Does it actually work? That is the test. So that is massive, okay, because now you save a lot of time, you actually get code that works. Now, if you're in my community, you know, okay, but why so I get I got some bugs. So at the moment, I only can test on my own system. Therefore, the test that is run, it's within my system. And what I'm trying to fix now, how can I test something outside my system? So what I'm building is an AI, my main AI, that runs other AI. So connect and test on other actual computer. This is deterministic test. Okay, it's no hallucination, it's not belief or something. So it's gonna do this deterministic test. So it's not even me that I need to test. Of course, I can check, I can work and see. But the idea is to, how can we scale this? Is to have deterministic scale also outside our system. And that is how we can actually prove that something works or not. So think about now all of this, okay? Complex already scenario. Difficult to manage for a human, because at the moment there is a few hundreds rules to follow. Okay, think about, more you work, more you have protocols, you are gonna have thousands of rules to follow. As a scale that for humans is basically become already impossible to follow, and it's gonna be more and more challenging. So the job that we need to do is remove the human from the loop when it's possible. To remove the human from the loop, you need rules, okay? Because you can only remove the human if you can trust the system. So without the logician, you can't trust the system, because it's a sort of constant hallucination. So with the logician, we force it into a reality. Now we can trust it. But how can we actually keep improving? Because that is the goal, right? We need an AI that can adapt, improve, and change, and so on. So how we can do this self-improvement? Self-improvement is it's tracking the mistake that we make in the AI collaboration, human AI collaboration, but also the AI when it works by itself. So how ResonantOS works, that again is a system that runs on top of OpenClaw, open source, free to download, so subscribe to get it. The ResonantOS, what it does, it's basically create memory logs. Okay, so at the end of the session, create this log where save not just what we've done. It's not like a summary of this is the minutes of a meeting. What it does is write, of course, that part because it's important, but also the lesson learned. I learned this thing. I made this mistake. Okay, the human learned this thing and he made these mistakes. Okay, so he tracked the human and the AI, but plus he had some elements that are gonna be used in the future for fine-tuning the AI on my specific work, on my specific way of thinking. So you're gonna get with this ResonantOS this ability of building something that is useful for the present, but also look forward for the future, where we are going to be needed to actually fine-tune our system for some specific functionality. Now, this document has, I made this mistake. Okay, so in the evening, there's going to be an AI that check all those errors. And what it does is say, okay, this error has been made once. Okay, I'm just going to track it and see if it happen again. Then there is this thing maybe that has been happening more than once. So now it's a behavior, it's a problem, it's a pattern. And now makes sense to write a rule for the problem. Because it's not one-off that happened because whatever, okay? Because someone made a mistake, it can happen, okay? And that thing doesn't need to impact the architecture. But if we see a pattern, then there is a need to make changes and improve the system itself. So what it triggers the a protocol that builds rules. Okay, again, this is a protocol. It's a protocol that has a specific steps and to format these rules. Okay, because rules, when we ask us to humans, so we use rules in a way that require intelligence. Okay, this is don't do this because it's bad for you. Okay, the word bad for you doesn't mean anything, but if we, for human means something, but for AI means nothing. Okay, because it cannot be measured. So AI needs specific things. So you can give example, you can give keywords, you can give a lot of elements that make something that is clearly, I can not do this when these specific things happen. Okay, I cannot tell you I fixed this bug unless I have the proof of it. Okay, a deterministic proof of it. So that is the idea. So what we need, basically, this protocol, what it does, it turns the problem into a series of steps and say, okay, this is how we build a rule. So you don't need to know, you don't need to remember, you don't need to be a machine to think in those terms, but you have a protocol, an AI itself, that actually run the protocol and write the rules specifically for the logician. That is how the AI keep improving. Okay, but there is another thing that can happen. So you can make maybe a mistake that you have a rule for. So the AI will check, okay, we have a rule for this mistake, why is still happening? So go back and check, okay, this is happened because this is, I don't know, was a bug in the sense the rule was not written properly or had some problem, or most likely is this is one of those cases where we didn't think about and still trigger the same problem. So now we can add this specific case to the rule and now it is covered. So the AI can do this basically two types of improvement. One, recognize rules that are not working as they should, and the other is creating new rules so it can keep getting better and better and better. Now, of course, you can trigger those rules manually. I mean, the creation of rules manually. Okay, you say, okay, I had this protocol, I got this idea, I want to work in this way. Okay, turn this into a rule. Okay, basically you create the protocol and then you fortify the protocol through rules. And now this is going to happen all the time in the way that you designed. Can you understand the power of this? So we are moving from an AI that maybe does, maybe it doesn't know, it doesn't do it, okay? Sometimes it doesn't know what to do. Every time that you need to do something, it's just gonna create a protocol to do it, okay? So it's not gonna be constant. That is, for an individual, is already, really, really taxing, really, really heavy to work with an AI that is always, uncertain. For a corporation, this is a must. Okay, there is a protocol. Those protocol basically means alignment. Okay, so you create this alignment, and now think about this new person that joined your company. He has this own. They have their own AI that is aligned, and now they can work specifically on whatever it is, because from the day one, because they know what the AI basically is gonna enforce protocol, be sure that the output is in line with the values and whatever missions and so on. Okay, so that is the solution for individual corporation to actually have an AI that is in line. Again, this is not something that we need to build. Okay, it's built, it works. At the moment is on alpha testing, meaning that is, of course, there's going to be bugs, that some functionality is not completely finished, but I use it. Okay, it's the only AI that I use and works amazingly. So my suggestion here is, think about your reality. Okay, who are you? You are someone that wants to build and tinkering and so on, or you are someone that just needs a machine that works. If you are someone that wants to tinkering, what my suggestion here is basically you are I call us AI Artisan. Okay, we should connect. We should work together. That's the plan. Okay, ResonantOS is open source and it's part of a bigger project. Okay, it's a way that we should work together and build this. There's a lot of things to build. I can't remember if I said in this video that I got a roadmap which is beautiful. Okay, what we are gonna build is amazing. I got a clear line of what is gonna be next. At the speed that we are going, I don't know how long it's going to take to this roadmap, but it might be just weeks, okay, really, really fast. So if you are instead someone that wants to use it, my suggestion here is test this. It's going to change the way you work with AI. It's extremely solid, okay, in the sense, having an AI that instead of hallucinating, actually follow those rules, self-improve, so it learns with you, okay, how you work, what is needed, okay, what's the whatever new protocol, new way of doing, remove, keep doing the same mistakes. It's huge. It's how AI is supposed to be, and there's no other AI that I know that actually do this. So I'm pretty pumped about this idea, and I hope you are as well. And to make it, I want to make it these things clear, okay? Because it really sounds like sci-fi. Yeah, no, it's not possible. It's not possible. AI cannot follow rules. Yeah, exactly. AI cannot follow rules. It's no AI that enforces the rules. It's a software. Okay, is an agent that doesn't have intelligence, has gates. Okay, you only go through if you've done this, okay, or if you do this in a specific way. That is the key. Okay, so it's binary. Our goal is to turn our work from be 100% on AI to change of a mix of things. Okay, some stuff is better done by basically software, and trust AI for other things. So that is what I wanted to share today. So like and subscribe, of course. Get this ResonantOS. Let me know how it works. And if you have a corporation, okay. So if you think about, okay, I need this in my company, we need to run some experiment. Okay, I'm building it in this way. That is because the alignment of corporation, that is the part that I forgot to say. So how do we align corporation? So the corporation means that is while the logician works within one single computer, to align a swarm of computers, basically people that work with AI. How do we do it? We do it through smart contract. Okay, this we use basically blockchain technology that enforce AI through the network. So the AI can only do another work with this other AI, can only do some elements in the network through going through those smart contracts over the blockchain. So if you never heard about blockchain, blockchain is is a decentralized system that it's one of the most secure. I mean, it's the most secure technology ever created by humans. But what it does, it works peer to peer. So what is happening is, if I want to work with that specific machine, there is a way to those machines to recognize themselves 100% secure, okay, through this smart contract. They can agree what to do, and they only gonna go through if, for example, if the values of the company is being used. Okay, so there are kind of way to control, like the logician does, but in a network. That's the solution. I'm gonna start experimenting with this because I know the technology, I know how it needs to work, but I'm gonna start experimenting myself on this with having multiple computers working in a network. Now, would be amazing also to experiment in a live scenario. That is, I mean, you need to take this risk, but it would be interesting to take, to experiment in a live business environment. The step that your business can have is huge. Okay, think about the AI follows the rules. Okay, you know which AI did this. Okay, which human and AI together did this. There's a lot of elements that really build alignments and security in the system. I love it. I hope you love it too. So thanks for staying until the end. Watch the next video. Like, subscribe to the newsletter so you can test this ResonantOS.